So here we have acetic acid and potassium hydroxide, which makes potassium acetate and water. So now we will identify the acid, the bronzolaric acid, which is the acetic acid. And next, the bronzolaric base, which is the potassium hydroxide. Next, we will be getting into the transfer of electrons from the oxygen that is connected or sharing electrons with the potassium to the hydrogen that is connected to the oxygen on the acetic acid atom. And we will use the purple to show the transfer of the electrons to the curved arrow mechanism. Now you have to remember that the curved arrow mechanism goes from the electron to the proton. It cannot be reversed because it shows the movement of electrons. As you can see, we are showing it now. Please excuse the drawing. I am not artistic. And next we will show the movement of the electrons connecting the oxygen and the hydrogen, highlighted in purple, to the oxygen, which will be turned green. Next, I will be showing the transfer of the electrons and how they were placed in the products. First, I'm going to show where the electrons that were moved to the hydrogen, how they were used in the product to form a bond between the hydrogen and the oxygen and water on the left side. Next, I will be showing how the transfer of electrons from the hydrogen to the oxygen made the oxygen more negative in the product on the acetate ion. Next, we will be identifying the conjugate acid and the conjugate base. Now that the bronzolaric base was the potassium hydroxide, the conjugate acid pertaining to the base will be the water molecule. As for the bronzolaric acid, which was the acetic acid indeed, the acetate ion and the potassium ion would be considered the conjugate base to pair, the acid, the bronzolaric acid with the conjugate base, and the bronzolaric base with the